Hello everyone, what's up? Welcome to Catalysis by Vedantu. If I am audible and visible, please write yo in the chat box. You know the drill. As every day. तो और बताओ दोस्तों क्या हाल चाल? So today we are here to do this notorious chapter which hardly anyone pays any attention to, and this is the chapter of metallurgy. Yeah. Now the thing about metallurgy is it is a typical chapter of inorganic chemistry, but practically speaking in the industry is very useful because it tells you about all the ores and how to extract metals from them, and you know the entire world runs on that. So yeah, it's a very important chapter from a practical standpoint, but again, if you want to study it, it takes a lot of patience. So today we'll approach this chapter in a marathon style. I've collected a few questions for you, and along with those questions we'll try to revise as much theory as possible. Once again, to completely do this chapter from scratch, you have to do it from the NCERT. We'll discuss a bunch of important concepts today, but I would still recommend that you read the NCERT from top to bottom after this class as well. Now, one question that everyone is asking, sir, is JEE and NEET postponed? So I would like to tell you that JEE and NEET will now happen in the year 3020. So for the next 1000 years you have to chill. After 1000 years you have to give the examination. People, the thing is that right now the examinations have not been postponed, and since I am not someone who works for the government, I am not someone who works for the HRD ministry, I do not know. Okay, no one knows for sure right now, and once they do, each and every news channel out there will tell us when the examination is going to happen. Right now the dates are not postponed and they will happen when they're supposed to happen. Cool. So talking about the importance of this chapter, yes, every year one question comes from this chapter for sure. So let's get into it. Let's do the first question. So the first question is simple. This is actually a question of the mole concept. It's just that you need to know what galena is. Okay. So let's read the question. Galena, an ore, is partially oxidized by passing air through it at high temperatures. After some time, the passage of air is stopped, but the heating is continued in a closed furnace such that the contents undergo self-reduction. The weight in kilograms of lead produced per kilogram of oxygen consumed is... Simple question, nothing too complicated about it. So what you need to know is what is galena. Galena is an ore which is just the sulfide of lead. PBS is essentially what this ore is. Of course, there are lots of impurities, but this is what galena is, and a lot of you know that already. Very nice, good job. So now what is being said is that first it is passed through air. So my dear friends, what will happen in this process? Can you guys tell me? What is the first process that will happen over here? Oxidation will happen. So both lead and sulfur will get oxidized in such a fashion that you will have a lead oxide and you will also have SO3 that gets produced. SO3 तो नहीं बनेगा यार, SO2 बनना चाहिए, yeah, sulfur का oxide बनना चाहिए, yeah. So SO2 will get produced. Now what happens is that this lead oxide is reduced by lead sulfide. Okay, what happens in this case is you get lead as metal and you will also get some more SO2. Okay, this is the entire process that happens. So my dear friends, if you have to look at the overall process, if you just don't worry about whatever is happening in the middle over here, don't worry about the black things that we've written. The overall process that we are wondering about is lead sulfide plus O2 to give me lead plus SO2. Now this is a typical reaction that happens for galena. If you don't know the reaction, then you would have left this question. Yeah. So chalo. Now the good thing about this reaction is, do you realize it is already balanced? So inorganic chemistry is about knowing facts. If you knew the fact, brilliant. If you didn't know the fact, then my sympathies are with you. So this reaction is already balanced. There's no need to balance this reaction anymore. So the ratio of oxygen to lead is 1:1, isn't it? It's 1:1. So my dear friends, 1 mole of O2 is how much? 1 mole of O2 is 32 kilograms. I mean 1000 moles of O2. I can write 32 kilograms. And what is the molecular weight of lead? It's already given, thank God. Yeah. So for lead, 1 mole will be 207 kilograms. So if 32 kilograms of oxygen can give you 207 kilograms of lead, then my dear friends, 1 kilogram of oxygen will give me 207 divided by 32 kilograms of lead. Yeah. Now you have to tell me what's the answer. So 3 into 5 is 15. So 32 into 5 will be somewhere around 160. And 32 into 6 will be around. तो क्या आंसर आना चाहिए बताओ? Yeah. Somewhere more than 6. Yeah. 3 into 7 is 21. So somewhere in the middle of 6 and 7. I think 6.5, as you people are telling me in the chat box, it should be 6.47. Cool. Yeah. So this was a JEE advanced previous year question. It was asked in the year 2018. Just helped us revise what is galena and told us that inorganic chemistry is simple only if you know the reactions already. Take approximately 6.5 would be the answer. Great. Chalo, let's do the next question now. So the next questions like these are very common. Okay, you can expect such questions in every examination that you give. ठीक है? अब यहाँ पे the challenge is that you need to know the names of the ores and you need to know what is happening in them. Yeah, so again a memory based question. This is just general knowledge. There is no logic to this question. Yeah, this is a pure memory based question. So let's just write down what these different ores are made up of. Okay, so it's a table that is given in the NCERT. We'll see that table as well. Okay, so siderite is FeCO3. Even I don't remember all of these names, by the way. तो लिखते हैं एक एक करके. What is malachite? Okay, malachite is CuCO3 dot CuOH whole twice. Okay, then what is bauxite? Bauxite is aluminium's ore, so it is essentially an oxide of aluminium which has a bunch of hydroxides associated to it as well. Some number of hydroxides is there, 3 to 4. Then you have calamine. Okay, so calamine में क्या रहेगा दोस्तों? Calamine is basically your zinc's carbonate. Okay, and then finally you have argentite. Okay, so argentite of course is the ore of silver, and this is just a sulfide of silver. Cool. So these are the ores that we have. Now how do you remember these? Ratta marna padega bhaiya. You have to cram these up somehow or the other. Even I was looking at the list. I'll be 100% honest over here. So how do you remember this list? Just look at this list every 2-3 days. What is the list that I'm talking about? This is the list that is given in the NCERT. Okay, this is one of the most, these are the more important ores, but there are some ores that are missing from here. For example, galena is missing, then this argentite is missing. Some more ores like dolomite, etc. are missing from this list, but at least remember these ones. Okay, यहाँ पे आ जाएगा lead sulfide. And argentite will be your Ag2S. So these, please remember, look at this list like every 2-3 days. Just look at this list once again. Every 2-3 days, just look at this list once again. Your memory will help you a little. It's a memory based game, man. These names are all historical in nature. So yeah, gotta remember them somehow or the other. So now that we know what these are, the match the column becomes very simple. Yeah, which ones are carbonates? Siderite is a carbonate, malachite is a carbonate, and your calamine is a carbonate. Great. Then you have sulfides. Which ones are sulfides? Only argentite is a sulfide over here. Then you have hydroxides. Okay, so malachite is a hydroxide and bauxite also has a bunch of hydroxides in it. Yeah, and then you have oxides. So bauxite yet again is an oxide as well. Cool. Azurite is missing. Lots of different ores are missing from that list. I agree, but at least remember those which are given in the NCERT. Okay. Shivansh is asking which is your favorite, organic, inorganic or physical. Organic is my favorite. Least favorite would be inorganic, of course. ठीक है, चलो जी, हो गया. Cool, done, nice. There's nothing to explain in this question, man. Like क्या करें? And this is the JEE Advanced question, by the way. JEE Advanced also asks questions like these. So in NEET and JEE Mains, I'm pretty sure you can expect questions like these again and again. Devesh is asking, do you make dinner on your own? Yes, Devesh, I do. In case I don't want to cook, then I order food from Swiggy. Chalo, next question. Copper is purified by electrolytic refining of blister copper. The correct statements about this process are: my dear friends, this electrolytic refining process is something that you would have learnt about in your earlier classes as well. I think in 8th or 9th or 10th class, they teach very, enthusiastically about this process. That, when you have an anode and a cathode, then if you pass the electricity through it, then the cathode, the impure anode, the impurities will settle down and the ions will move, and then they will settle upon the cathode. So cathode will be pure, anode is impure, etc., etc. Yeah. So I hope you remember that from earlier classes, because in 12th class to remember this is very hard. Still, good that you are here. We will understand what this process is. ठीक है? तो होता क्या है यहाँ पे? I'll revise this process for you over here. I have this excerpt taken from a very rare book. This book is found on Jupiter. So yeah, let's revise it from this book. So this is the setup that we have, people. All right, and you have a cathode and you have the anode. All right, now on the cathode you have this reduction reaction that happens. On the anode you have this oxidation that happens. Typical. Yeah. So on the anode you will get ions, and the ions will travel through this through the electrolyte. Electrolyte is also copper electrolyte. Yeah, generally you can take CuSO4 over here, so that the ions that are created, Cu2 positive ions, they can go towards the cathode. Yeah. So my dear friends, the cathode over here has to be pure, the anode has to be impure. The anode keeps losing the ions which keep traveling towards the cathode. So the cathode keeps getting bulkier, anode keeps getting smaller and smaller, and all the impurities that were there in the anode just get deposited on the bottom of the tank like this. It is known as anode mud. This particular method is known as the electrolytic refining method. Okay, you can read it if you want. I've anyway explained everything. So the impurities from blister copper deposit that gets deposited as the anode mud. Okay, this is where you take blister copper. What is blister copper? I'll tell you about that in some other question. I have a question for that as well. So whatever impurities were there, antimony, selenium, tellurium, silver, gold, platinum, they can also be separated, refined and sold later in the market, so that you meet the cost of refining. And zinc can also be refined in the same manner. ठीक है, जिंक को भी इसी तरह electrolytically we can refine. So let's read this question now. Impure copper strip is used as cathode. No, cathode is always pure. This statement is incorrect. The next statement says acidified aqueous CuSO4 is used as electrolyte. Absolutely can be used. Pure copper deposits at the cathode 100%, and impurities settle as anode mud. Once again a JEE Advanced question. Brilliant. Okay. So Priya, we are doing one class for metallurgy, and in this class, as you see, we are revising the concepts while solving some questions. Okay? This is an all-in-one class. Sanjay, yes, I only teach on YouTube, my friend. Cool. So people, if you enjoy this method of revising while solving questions, please hit that like button. Also, this is exactly how you should solve inorganic chemistry. Take questions, solve questions, and then when you realize, okay, this is something that I don't know, open the NCERT, read about it, then go back to the question. Efficient. You will be solving questions and revising at the same time. Alright? Chalo. Now the next question that is there is from a very important concept, and questions from this can come for sure in your examinations. It's from this concept of the Ellingham diagram. Yes, that's what it's called, right? So my dear friends, these diagrams essentially are diagrams of the delta G Okay, you are assuming that these reactions are at equilibrium. That's the assumption that goes in these particular diagrams. So this diagram tells you only about the thermodynamics of a reaction. It does not tell you anything about the kinetics of the reaction. So that is one drawback of these diagrams. Another drawback is that this diagram assumes that all of these reactions are at equilibrium already. It's talking about delta G naught over here. Okay? So the formula that we are using over here is delta G naught equals to minus RT ln K. Yeah, this is what is going over here as the assumption. So we are assuming in this process that we are already at equilibrium. Now you know that it is hard to establish an equilibrium if you have a solid substance to start with. Yeah, because solid substance will never be there in the equilibrium equation. If you start from, let's say, copper solid and then you're oxidizing it to some gas or liquid structure. Just an example. Do you realize that the solid will always just be a constant value in the equilibrium equation when you are calculating the equilibrium constant? So this methodology of these Ellingham diagrams doesn't really work when you have solid things to start with. So it works better at temperatures where everything is molten. When everything is melted, that is when it finds better application. But anyway, for all practical purposes, this idea can be used. Now, what you need to figure out over here is that for the overall process, your delta G has to be negative. Okay, for the overall process, your delta G has to be negative. Let's just read the first statement. You have to choose the correct statement, by the way. Which one is the correct statement? That's what you have to choose. So let's read the first statement and let's try to figure out whether this process can happen or not. Okay, what it says is at 1400 degrees Celsius, aluminium can be used for extraction of zinc from zinc oxide. So at 1400 degrees Celsius, this is the reaction that you're trying to do. You're trying to take zinc oxide into zinc. This is one reaction that you're trying to do, and the other reaction that you're trying to do is you are using aluminium. Okay, you are using aluminium. So what will aluminium do? The oxygen that is produced over here, aluminium would react with it and form the oxide. Okay, so when you combine these two reactions at 1400 degrees Celsius, is the Gibbs free energy negative or positive? That's what we have to figure out. ठीक है जी? Simple idea. Sometimes to understand Ellingham diagram, it takes a little bit of time. So this example helps us a lot. So at 1400 degrees Celsius, we need to understand whether the Gibbs free energy of this entire process is negative or not. All right. Now let's look at the first process. Aluminium plus oxygen going to Al2O3, 1400 degrees Celsius. By the way, this temperature over here, this one is 800 degrees Celsius. It's not printed over here in the question. So 1400 will be somewhere over here. कहीं इतना यहाँ पे होगा 1400 या. So my dear friends, now at 1400 degrees Celsius, if I go, what is the Gibbs free energy of the aluminium reaction? Gibbs free energy of the aluminium reaction is approximately, okay, I'm saying approximately minus 900 kilojoules per mole. Okay, approximately. यहीं से just taking an idea from here. Yeah, great. Now let us try to see what's the energetics of this reaction. यहाँ जाते हैं ऊपर. Somewhere over here, yeah. Somewhere over here. Now, my dear friends, the reaction that is given in the diagram is zinc oxide plus zinc plus oxygen gives zinc oxide. But we need the opposite reaction, isn't it? So let's just see what is the energy over here. Yeah, this one is. Yeah. This one will be somewhere around plus 200 kilojoules per mole. Do you understand why there is a plus sign? Because if we want to go from zinc to zinc oxide, then you are releasing 200 joules of Gibbs free energy. Yeah, then the Gibbs free energy is negative. But we want to do the opposite process. So the Gibbs free energy will be opposite. It will be positive 200. So my dear friends, when we combine these two energies together, do you realize the overall delta G naught will be negative? The overall delta G naught will be negative. So yes, at 1400 degrees Celsius, this process can definitely happen. Okay, this process can definitely happen. All right. Now let me look at the next three processes as well, just to see. At 500 degrees Celsius, coke, that is carbon, can be used for the extraction of zinc from zinc oxide. Acha. So we want to do the opposite over here. So we want to do a plus 200 kilojoules per mole for the second process. Yes, and at 500 degrees Celsius, acha, plus 200 तो नहीं होगा यहाँ पे, sorry. We are talking about 500 degrees Celsius temperature. So this one, yeah, these points. So this is one point that I'm looking at, somewhere around let's say plus 500. And for coke को क्या करना है अपने को? We have to use coke, yeah, to eat up all the oxygen that zinc oxide will be producing. So we need to do this particular reaction. ये क्या बोल रहा है यहाँ पे? This is giving me energy somewhere around minus 400. So overall Gibbs free energy is positive. The reaction will not happen. Did you understand this logic? If you did not understand this logic, please tell me right now. Okay, tell me right now. This is the basic logic. Now, of course, you can think about shortcuts. If you just look at the Lingam diagram, if there's a process at the bottom, the process at the top, its opposite can happen. Okay, whatever process is at the top, its opposite can happen. That's what you need to remember. Okay, so for example, abhi at this temperature, zinc to zinc oxide is at the bottom, carbon plus oxygen to CO is at the top. So do you understand? This process, if you take its opposite, then it can happen with zinc plus O2 to give zinc oxide. ठीक है, मैं फिर से समझा देता हूँ, not a problem. देखो, let's draw this Lingam diagram once again. It takes a little bit of time for this to be understood, so don't worry, I'll explain once again. Okay, my dear friends, let's say there is this line. Okay, एक line ऐसा बनाते हैं अपन यहाँ पे, and let's say there is the other line which is in green color, मान लो something like this. Okay, let us say the green colored process is A plus O2 to give AO2. ठीक है, and let's think that the blue colored process, I'm taking a very theoretical example over here. Let's say the blue colored process is, यहाँ से कोई example ले लेते हैं. Let's take B plus O2 to give BO2. घटिया, ठीक है, right? So now let us define two temperatures. Let's define temperature T1 and let's define temperature T2. Pay attention. Okay, at T1, okay, at T1, so now this particular is the axis of delta G. So let's say the delta G over here is minus 100, the delta G over here is minus 500, and the delta G over here is minus 1000. That's what's happening over here, yeah. Fine. Now let's try to understand. At temperature T1, if I go up over here, okay, if I go up over here, how much Gibbs free energy is the first process releasing? B plus O2 to give BO2. Okay, what is the Gibbs free energy of this process? Delta G is equal to somewhere around minus 400 approximately, yeah. Can you see this arrow that I've made? Approximately minus 400. Acha. Now my dear friends, my question to you is, what is the Gibbs free energy of AO2 going to A plus O2 at this temperature? How much is this? So once again, for T1, let's go to the curve that represents A plus O2. Let's go to the line that represents A plus O2. This is the point that I'm talking about. This point is, let's say, somewhere around minus 250. Yeah, let's say this point is somewhere around minus 250. घटिया example ले रहा हूँ मैं. Don't take these values very seriously. Let's say this is somewhere around minus 250, है ना? Now my dear friends, this minus 250 is for the process A plus O2 going to AO2. So what will the Gibbs energy be for AO2 going to A plus O2? What will be the process where AO2 is getting reduced into A plus O2? Delta G will be positive 250. isn't it? Delta G will be positive 250. If I combine these two together, my dear friends, the total delta G is a negative value. Delta G being negative is a spontaneous process. So yes, this process can happen. As simple as that. Do you now understand how to define the feasibility of a process? ठीक है? What I was saying is, whichever process is at the top, its opposite can happen. Okay, whichever process is at the top in this region, AO2 is at the top, right? A plus O2 going to AO2, this is at the top. So in this temperature region, the opposite of this process can happen with B plus O2 going to BO2. I'll repeat the statement in Hindi. यार इस टेम्परेचर रीजन में ना जो भी चीज ऊपर है उसका उल्टा हो सकता है. सो इस टेम्परेचर रीजन में आप देखो, अगर B प्लस O2 गोइंग टू BO2 हो रहा है तो इस प्रोसेस का उल्टा हो सकता है. ओके, AO2 गोइंग टू O2 प्लस A हो सकता है. सो किसी भी टेम्परेचर रीजन में जो भी प्रोसेस ऊपर है उसका उल्टा हो सकता है. सो कैन वी क्विकली डिफाइन व्हाट कैन हैपन इन दिस टेम्परेचर रीजन? इन दिस पर्टिकुलर टेम्परेचर रीजन, in this particular temperature region, you can check this if you want. What I can do is A plus O2 going to AO2. This can help the process of BO2 going to B plus O2. You can check this process is feasible. Feasible means possible, can happen. Okay, got it? So जो process ऊपर है, whichever process is on the top, its opposite can happen. That's the idea. Okay, that's a hint. You can think about multiple combinations. If the top process is happening straight, then will the bottom process happen in the opposite manner, etc., etc. You can think about it, but the basic hint that you can take is the top process, its opposite can happen. How do you figure it out? This is the number game that you have to play. Got it? I hope everyone understood this. So once again, let us verify. Can you verify the last point for me? Third point is incorrect. You can verify the third point yourself. Can you verify the last point for me right now? At 800 degrees Celsius, which is this temperature, copper can be used for extraction of zinc from zinc oxide. So what are the two processes that we need over here? In point number 4, one process that we need is zinc oxide going to zinc plus O2 at 800 degrees Celsius. What is the energy that it releases? This much. तो 600 और 300 के बीच में, मान लो 500 कुछ 400 something. Yeah. So let's say this is approximately going to take 500 approximately. Yeah. ठीक है. I'm just being approximate over here. And the other process is copper. Copper क्या कर रहा है? अच्छा, copper is over here. So Cu plus O2 to give me Cu2O at 800 degrees Celsius. It is releasing how much energy? Minus 200. Overall delta G is positive. This process cannot happen. Fine. Got it? As simple as that. ठीक है? So only the first process over here is possible. Process number 2, 3 and 4 cannot happen. I hope you understood all about the Ellingham diagram. If there's any doubt, you can ask me. Okay. Ganesh, at the point of intersection, you don't want to do a reaction. That's all, bro. Everything is happening in the industry, right? So at the point of intersection, like, why would you want to take this temperature for a process with, zinc and carbon? Don't take this temperature. Just take something more than that or something less than that, depending on whatever you want to achieve. Okay. Chalo, badhiya. Let's go back to the typical class structure. Thank you so much for your compliments, people. Awesome. Now let's go on to the next question. Carbon-based reduction method is not used for the extraction of which of these? Carbon-based reduction method is not used for the extraction of which of these? How do we do this question? Once again, the answer lies in Ellingham diagrams. Let's look at this, which I have taken from the NCERT itself. So what is the carbon's curve? This is the carbon's curve, okay? ये जो कर्व यहाँ पे दे रखा है, not curve, I should say line. I don't know why I say curve all the time. this line that I have made in red now, this is your carbon's oxidation. So if carbon is getting oxidized, you can reduce some metals. Yeah. Now what metals can be reduced by carbon? All the metal lines that are above carbon can be reduced. All the lines are for oxidation, so their opposite processes can happen if the lines are above carbon. I'll repeat in Hindi. सब लाइनें जो हैं यहाँ पे वो ऑक्सीडेशन की लाइनें हैं. So जो भी कार्बन के ऊपर की लाइन है उसका रिडक्शन हो सकता है, उसका उल्टा हो सकता है. So my dear friends, copper can be reduced. Yeah, iron can be reduced. Zinc can be reduced because zinc के लिए यहाँ से आ रही है line. Yeah, at certain temperature zinc can also be used. But do you realize that aluminium and magnesium cannot be reduced using carbon? These two can't be reduced using carbon. Yeah, because they are below carbon right now, and whatever is below, its opposite can't happen. Whatever is above, its opposite can happen. Whatever is below, its opposite can't happen. What you need to do is you need to create the metals out of their oxides or carbonates. Carbonates can be decomposed into oxides. You know that very well. Yeah. So my dear friends, these metals, aluminium and magnesium, can't be reduced by carbon. Okay, their ores can't be reduced by carbon. So tin हो सकता है, iron हो सकता है, Al2O3 can't happen, and magnesium can't happen. So the answers over here will be C and D. Factual question again, but the idea stems out of the Ellingham diagram. Cool, that is the basic idea behind it. Chalo. Now let us move on. Again, fact-based question, people, nothing too complicated about it. Sulfide ores are common for the metals. So yeah, it's just fact. Lead sulfide we've already seen, silver का sulfide we've already seen, copper as well exists as a sulfide. ठीक है, copper के भी sulfide ores exist करते हैं. So let me see the list once again. As you can see, copper में भी there are sulfide ores that are present. Pyrites have copper and iron both with sulfur. Okay, so in aluminium I am pretty sure you can see that sulfides don't exist. ठीक है, aluminium does not exist with sulfur, copper and lead and silver do. So the answer is A. Fact-based question. Chalo, let's do the next one now. In cyanide extraction process of silver from argentite ore, we've seen what argentite is. The oxidizing and reducing agents used are, again fact-based question. Sahil, yes man, I was waiting for you yesterday as well towards the end of the class, but I think you left yesterday, so no problem, we'll talk about that today, bro. Computer technique, is it so? I had given them a meme. Let's see. भेजा तो था उनको मैंने meme, उनने डाला कि नहीं पता नहीं, लग जाएगा पता. चलो. So my dear friends, once again this is also from the NCERT. Let's revise this process. Let's read it out. In the metallurgy of silver and gold, the respective metal is leached with a dilute solution of NaCN or KCN. So this is your cyanide extraction process. Whenever you have gold or silver, you leach them with sodium cyanide or KCN in the presence of air for oxygen. Okay, ठीक है. So this is what is necessary. Now from which the metal is obtained later by replacement. Let us understand the processes over here. Metal. Okay, metal. These are very nice, present in the ores. Reacted with Cn negative and water and oxygen in air. Okay. What this does overall is that it creates your metal cyanide. ठीक है, this reaction creates your metal cyanide and OH negative. ये बन गया MCN whole twice negative charge. So over here you have taken your metal into a +1 oxidation state. Yes, metal 0 oxidation state to metal +1 oxidation state. Great. Now you take this and use zinc to reduce the metal back to a pure source. ठीक है. So first use oxygen for oxidation and then zinc for reduction. That's the idea. ठीक है जी. So metal, cyanide, reduce that cyanide using your zinc. Simple idea. Now hence the reaction over here will be oxygen and zinc dust respectively. Yeah. पहले oxygen use करेंगे and then we will use zinc. Again fact based question, memory based question, no logic, nothing. Let's go to the next one now. And by the way, I will give you the PDF of this class so that you can revise. Otherwise, just read the NCERT please after the class. It will help you for sure. चलो ये करते हैं. Oxidation states of metal and minerals, hematite and magnetite respectively are. See, these are minerals of iron. Hematite is Fe2O3 and magnetite is that weird one, Fe3O4. Yeah. I think you remember these from earlier classes as well. Might remember them. मेरे को कभी नहीं याद रहते. So in Fe2O3, my dear friends, your iron is in a +3 oxidation state. Magnetite is essentially a combination of FeO and Fe2O3. Yeah. So over here you will get a +2 and a +3 oxidation state. So hematite has +3 and magnetite have both. Magnetite has both +2 and +3. So option number D is the answer. ठीक है. तरुण सिली मिस्टेक कर दिया दोस्त. ऋषिका सिली मिस्टेक. अमर सिली मिस्टेक ब्रो. Hematite is Fe2O3. क्या कर रहे हो यार. ईशानी, how can there be +2 in hematite? Fe2O3 होता है यार वो. Ipsita, which reaction did you not understand? First reaction बोले तो कौन सा? अमर ब्रो, Fe2O3 में आयरन की ऑक्सीडेशन स्टेट क्या होती है? अरे भाई, व्हाट आर यू डूइंग? Fe O -2 टोटल बोले 6 +3 टोटल बोले 6. सो आयरन इज +3 hematite +3 hematite. अरे भैया, why are people giving me C as the answer? What happened, bro? Next one. Okay, the ore that contains both iron and copper are. Ghatiya question again. गुणेश, कौन सा क्वेश्चन नहीं आया दोस्त? सब तो समझा दिया, अब और क्या करूं? सब समझा दिया, बोलते आया नहीं. अरे भैया सुन तो लो. ऑडियो के बिना मूवी देख लोगे तो कहां से समझ आएगी? सब टाइटल थोड़ी लगे हैं. हाँ जी, दी ओर दैट कंटेन्स बोथ आयरन एंड कॉपर. देखो, वीव सीन दिस ऑलरेडी. कॉपर पायराइट्स आर कॉपर, आयरन एंड सल्फर. या CuFeS, copper pyrites, right? So this is CuFeS2, isn't it? Yeah. Now there are other ores which are given over here. I'll just tell you what those are. If you can remember, brilliant. If you can't, then you're in the same boat as I am. So malachite is an ore of copper. This is Cu2CO3. Okay, this is a copper carbonate which has some hydroxides associated with it. This is your malachite. Your dolomite, okay, I have these saved in my other computer right in front of me. This is an ore of calcium, CaMg, CO3 whole twice. Okay, so this is a calcium and magnesium ore. And then you have azurite. And azurite is again an ore of copper. It looks nice and blue in color. So this is your copper carbonate with some OH as well. So malachite and azurite are similar to each other. Their compositions are slightly different, that's all. ठीक है, fine. So these are the ores. In case you want to remember, you can remember, otherwise forget about it. Okay. So the ore that contains both iron and copper is 1. Simple. Chalo, let's do the next question now. This is important because this process is necessary for us to remember. Questions from this process have come time and again in the examinations. So the question says Hall-Herold's process is given by. What is this process? So this process is just a fancy name for the electrolytic metallurgy process of aluminium. Okay, electrolytic cell extraction of aluminium. This is how it is done. So this is the cell that we create. Inside the cell you put your ore of aluminum, Al2O3, and you put some NaAlF6. Okay, Na3Alf6. Fine. This is melted and put inside the system. So there will be an anode which is made up of graphite. There will be a cathode which is also made up of carbon. So both the anode and cathode over here are carbon. Yeah, graphite anode and silver vessel with carbon lining, that is the cathode. Okay, there's a copper clamp, there's a nice cell, you pass electricity. Yeah, one electricity is being passed through here, anode, and this is the cathode. Okay, so now when the reaction happens over here, you are essentially reducing the ore. Reduce हो रहा है यहाँ पे ore. So the reduction process is essentially Al2O3 plus carbon going to aluminium plus CO2. Okay, got it? Al2O3 plus carbon going to aluminium plus CO2. It's just done in the presence of electricity. We just understood that it can't be done thermally. Do you see over here in this diagram, we understood that it can't be reduced using carbon thermally, isn't it? Because just with heat, my thermodynamics is not working out. So you need to force this to happen. How do you force it to happen? You can force it to happen by passing some electricity through it, right? So aluminium can be reduced by carbon by forcing it through electricity. This process is known as the Hall-Herold's process. And if you want to read about it, we can do that quickly. In the metallurgy of aluminium, purified Al2O3 is mixed with Na3Alf6 or calcium fluoride as well, which lowers the melting point of the mixture. It becomes easier for it to melt and adds conductivity, yeah, because ionization is there for sodium, aluminium, fluorine, CF2. Ionization is there, so it becomes conductive in nature. You want to pass electricity through the solution. So this fused matrix bole to this melted solution just sounds fancy when you call it fused matrix. This fused matrix is electrolyzed, and the steel vessel with lining of carbon acts as cathode and graphite anode is used. The overall reaction, which we've already seen, Al2O3 gets reduced by carbon. This process is known as Hall-Herold's process. Okay. So thus the electrolysis of the molten mass is carried out in an electrolytic cell using carbon electrodes. Oxygen liberated at anode reacts with the carbon anode, producing carbon monoxide and carbon dioxide. So जो carbon है anode पे, that is combining with the oxygen to give you the CO2, and in this way, for each kilogram of aluminium produced, approximately half a kilogram of carbon anode is burnt away. This information might be asked in the examination. Okay, so the electrolytic reactions, as you can see, on the cathode you will have the reduction and on the anode you will have the oxidation. As simple as that. So on the anode the carbon will get oxidized, cathode pe aluminum will get reduced. Typical anode oxidation, cathode reduction. ठीक? Sorry. Yeah, anode oxidation, cathode reduction. Fine. This is your Hall-Herold's process. So my dear friends, over here the answer would be option number C. Got it? Done. Let's move on to the next question now. बोल के मेरा दिमाग फट जाता है. चलो, the next reaction now is which one of these does not define calcination? Calcination and roasting, two processes. Do you remember? Calcination is just heating the metal. Roasting is heating the metal in the presence of air. Which one of these is different? Jayant, it is just acting as the cathode, bro. कैथोड ग्रेफाइट का मतलब कार्बन का वो बनाना था अपने को, ग्रेफाइट मेक सेंस. बोथ एनोड एंड कैथोड आर टेकन ऑफ कार्बन एसेंशियली. ठीक है. Maria D'Souza, there is nothing to understand in this that reaction, my friend. It's just a reaction that happens. Aluminium is getting reduced, carbon is getting oxidized, redox reaction. Aluminium is going to metal, carbon is going to oxide, redox reaction. What's there to understand over here? This reaction is just forced via electricity. Okay, and if you don't know redox reactions, then please read the redox reactions chapter from the NCERT, or just watch the redox reaction marathon that we've done. Okay, it's just that you are forcing this non-spontaneous reaction to happen by passing electricity as the source of energy for it. Okay, so kithe chala gaya? This one. So people, this one, the second thing over here which you are doing with copper, this process is known as the process of roasting. Okay, this is the process of roasting. All the others are calcination. So these three reactions, 1, 3, 4 and 2, all of these reactions are given straight away in the NCERT. Okay, heating in the presence of oxygen is known as roasting. Just heating them to separate the impurities to a certain extent to get your oxides out of complex species like carbonates, that is known as calcination or smelting. Sorry, roasting and smelting are one thing. Calcination is in the absence of any extra air. Okay, so it involves heating when volatile matter escapes, leaving behind the metal oxide. Okay, so it's just a way of concentrating the metal oxide. Fine. Okay, very simple. Yeah, Naveen, I see what you did there. Anyway, the next one. The idea of froth flotation method came from a person X, and this method is related to the process Y of ores. X and Y respectively are. By the way, people, this is a JEE question. Okay, I don't know why students are scared of JEE examinations and NTA. See, this is such a beautiful question they're asking. So I am pretty sure you remember this one. Yeah. And I'm pretty sure you remember this one from your 9th class as well, or 8th class or 10th class. I don't know when you studied metallurgy in your elementary school. Yeah? Do you remember? There was a washerwoman and she was washing the clothes of miners, and then she realized that the dirt and dust settles at the bottom, but the copper particles get collected in the froth. When you wash, when you have that froth, those bubbles that get generated from soap, copper particles were being carried on the top because of that soap. Soap ke andar there were copper particles as well. So this led to the idea, this led to the invention of the froth flotation method, where you would use these soap kind of materials, okay, some long chain oils, and generate froth, and this froth would carry the metal, bring it to the top, dust and dirt will settle on the bottom. Yeah, so the washerwoman helped us innovate this method, and this is a method of concentration of the ores. This is what the system looks like. So there is a pulp of the ore and that oil that causes the froth to form. When you rotate this paddle, lassi banane ka iska ekdam. Okay, so when you make the lassi of this ore, the mineral froth comes on the top, and at the bottom you would have your impurity. Cool. So froth flotation is basically make lassi out of the ore. As simple as that. Chalo, next question. Mark the correct statement. So my dear friends, now in this question what we will do is, we will look at this question and we will revise a few more methods from metallurgy chapter. Okay, धीरे धीरे ये भी करते हैं. So man, glad you're enjoying. Pine or eucalyptus oil, absolutely science priya. I know Kritika, it is perhaps the weirdest. चलो जी बताइए क्या चल रहा है यहाँ पे. So, my dear friends, there are a few statements over here. The first statement says leaching of bauxite using concentrated NaOH solution gives sodium aluminate and sodium silicate. The second one says Hall-Hérold's process is used for production of aluminium and iron. नहीं, Hall-Rahl's process is used only for aluminium. This is incorrect. Third one, blistered copper appears blistered. Blistered copper appears blistered because of the evolution of CO2. And the last one says pig iron is obtained from cast iron. So let's take the opportunity right now to revise more things about metallurgy using the statements A, C and D, and then let's figure out which one is correct. For the first statement, let's try to read about leaching of alumina from bauxite. Okay, so let's read it carefully. This is going to serve a revision for us. The principal ore of aluminum, bauxite, usually contains silicon dioxide, SiO2, iron oxides and titanium oxide as impurities. So you need to concentrate your aluminium. Yeah. So the concentration is carried out by digesting the powdered ore with a concentrated solution of NaOH at 473 to 523 Kelvin. It's a very dangerous process, by the way. In the mines, if you see this process happening in the metallurgical industries, I'll show you a video very soon, don't worry. So these processes, on paper they look very simple, but in reality these are very dangerous processes. So you have concentrated NaOH at such high temperatures and such high pressures. गलती से पास चलेगे तो जल जाओगे. You will burn if you go close to this process happening. Yeah. So this way the Al2O3 is leached out. Okay, leached out बोलो तो comes out of this particular system as sodium aluminate, and SiO2 also comes out as sodium silicate, leaving all the impurities behind. ठीक है, so solution सा बना था. Out of this solution, this Al2O3 is leached out. Okay, so the aluminate in the solution is neutralized by passing CO2 gas and hydrated Al2O3 is precipitated. At this stage, the solution is seeded with freshly prepared samples of Al2O3, which induces precipitation. My dear friends, what is this? This is your Le Chatelier's principle. This is your Le Chatelier's principle. Yeah. Do you remember the solubility of salts? Solubility of salts, if you had a little more of the salt, it will start getting precipitated. Yeah, because once the solution is saturated, add any more salt and precipitation will start happening. Once precipitation happens, if you take away the salt, you can keep moving the reaction forward. Typical Le Chatelier's principle. Yeah. So over here, your sodium aluminate is added to carbon dioxide to get Al2O3.XH2O and sodium bicarbonate is produced. ठीक है, so sodium aluminate में you add carbon dioxide, you get baking soda and you also get Al2O3.XH2O, right? This is not exactly baking soda because this is aqueous right now, just making it a little easier to remember. And then the sodium silicate remains in the solution and hydrated alumina is filtered and heated to give back pure Al2O3. So in this solution, as you know, there were aluminates of aluminium and sodium silicon both. You precipitated the aluminium silicate just by putting a suitable salt, extracted it out, so the silicon remains inside the mixture, aluminium is obtained, and then this hydrated salt can be dehydrated at such high temperatures to give you the Al2O3, and then this can be taken through the Hall-Rahl's process to give you aluminum. Yeah, ठीक है. Suyash Chinchmalatpure, why do you want me to pronounce your surname? Right. So the first statement over here, leaching of bauxite, which is the ore of aluminium oxide and hydroxide. Yeah, that's the bauxite. Bauxite has some impurities. When you leach it using concentrated NaOH, it gives you sodium aluminate and sodium silicate both. Fine. Third one now. Hall-Rahl's process, something that we've already done. Blistered appearance of copper. अच्छा, ये भी देखते हैं क्या है. What is this blistered appearance of copper? चलो, ये आता है. Now let's come to copper. Okay. So copper is generally present as sulfides. Yeah. So you can oxidize them to make oxides. Yeah. CuS can simply be heated up in air. Eventually, it gives you CO2O. Yeah. So Cu2S से बना Cu2O. Now when you have the Cu2O, you can reduce it As we saw from the Lingam diagram, this process can happen easily. Yeah, Cu2O lies on top of the carbon line. So this process can happen easily using some thermal conditions. Okay? So copper is produced and carbon monoxide is at the side. So in the actual process, the ore is heated in a reverberatory furnace. Garam kiya mast isko. After mixing with silica. In the furnace, iron oxide slags. Okay, slag bolo to becomes that impurity which we need to take away. It slags off as iron silicate. Okay, why do we put silica? Because we want iron to combine with it and go away so that we are left with copper. Okay, so the copper that is produced is in the form of copper matte. This contains Cu2S and FeS. So what happened? The iron oxides that were present, you add them to silica, slag gets produced. Side pe nikal gaya slag. Yes. Now this copper matte is then charged into silica lined converter. Okay, once again, फेंक दिया एक converter में जहाँ पे silica की lining है. So some silica is added and hot air blast is blown to convert the remaining iron impurities, take them away, and Cu2S and Cu2O are converted to metallic copper. So what are the reactions happening? Iron impurity with oxygen, FeO with silica, slag once again, copper with oxygen to become copper oxide, and then this oxide and sulfide go through self reduction to create copper at the end. This is just a summary of the process that happens. Again, you have to read this 2-3 times for it to sit in your brain. Overall, what is happening over here? Overall, what is happening is the ore was a sulfide ore and there were some iron impurities. Okay? Iron impurities are taken care of by putting silica. They come out as slag. The copper is oxidized partially to Cu2O. Then Cu2O and Cu2S are combined together. They undergo self-reduction like we did for galena. Yeah, and you get copper metal at the side. That is the basic process. चमका कॉपर लेने का, आधा ऑक्सीडाइज किया, वो खुद को रिड्यूस करके कॉपर बनाएगा. जो आयरन की इंप्योरिटी थी उसको सिलिका के साथ कंबाइन करके स्लैग बना के फेंक दिया. That's the basic process. Okay. Got it? So now, my dear friends, in this case, let me show you the screen once again. The solidified copper obtained has a blistered appearance due to the evolution of SO2. ये देख रहे हो? There is an evolution of SO2. So when copper gets formed, SO2 gets liberated. So there are some cracks. There are some blisters on the copper solid. That is why it is called blister copper, because of the SO2 gas that gets evolved, not carbon dioxide. Okay, so over here it says blistered appearance is because of evolution of CO2. No, it is because of SO2. Incorrect. Fine. Then the last point that we have, pig iron is obtained from cast iron. Let's study about iron now. So this is what happens with iron. Okay, iron obtained from blast furnace contains about 4% of carbon and many impurities in smaller amounts. Okay, so this is known as pig iron. Now pig iron can be purified into cast iron. How is it done? You take cast iron by melting pig iron with scrap iron and coke using hot air blast. So this one has slightly lower carbon content, about 3%. It's extremely hard and brittle. Then the more purified form of iron is wrought iron. Yeah. So pig, cast, and then wrought. Pig is impure, cast is in the middle, wrought is totally pure. Yeah, not totally pure, still has some carbon impurities, but very less. Okay, so my dear friends, over here it says pig iron is obtained from cast iron. No, it's the opposite. It's the other way around. Cast iron is obtained from pig iron. So this statement is also incorrect. Now there was a very interesting word over here, the blast furnace. What happens in the blast furnace? See, blast furnace is used in the extraction of iron, and it is extensively used in the extraction of steel, in the formation of steel. So all the steel industries that are there, they all have these blast furnace mechanisms. Let me show you a diagram to understand what happens in the blast furnace, and then I'll show you a very interesting video. Okay, उस वीडियो से और मजा आएगा अपने को. So let's see this. Okay, so on the top you add the iron ore, you add limestone, and you add coke. Coke is there for reduction. Okay, why do we put limestone? Limestone is there to take away the impurities, okay, to slag the impurity. Okay? And why do we have the ore? Because we want to purify the ore, right? Cool. So what happens is, at the bottom of the furnace, so this furnace is very, very huge, like it's super huge, it's as tall as huge buildings. Okay, so from the bottom you are producing, providing a lot of hot air. Okay, this air is heated up to a very high temperature. Okay, so very hot air around 2100 Kelvin is put at the bottom, and as you go up the temperature decreases. So these reactions happen at different temperatures. Okay, at very low temperatures, somewhere around 800 to 1000 Kelvin, these reactions happen. Okay, these happen in the area of 800 to 1000 Kelvin. Okay, so your Fe2O3 is turning into Fe3O4, then Fe3O4 is again turning into FeO. Essentially you are just step by step reducing it. Initially all is +3 iron, now there is some +3 and +2. You take this +3 and +2, you convert it into all +2 iron. Okay, fine. And in this process as well, the limestone gets converted into calcium oxide. This calcium oxide is then used, okay, this calcium oxide is then used to take away the dirt, silica impurities. So this comes out as slag, and these happen at higher temperatures. Okay, this happens at 1200 to 1800 Kelvin temperatures. Okay, and what are the reactions happening over here? Your +2 iron is now converted into a 0 iron. So step by step reduction, +3 to +2, +2 say 0. Other process are oxidation of coke. That is pretty obvious. Yeah, pretty obvious, pata hi hai. Cool. So my dear friends, this is what the blast furnace process looks like, and at the end, from the bottom, you can take away pig iron and solid waste is taken away from the other side. Cool. So now let us look at a video. एक video देखते हैं इसकी. Just give me a moment. Let me get the video up. बड़ी मजेदार सी वीडियो है यार. Let's try to see if that works. Just a second, okay? Let me hide myself somewhere. Okay. So yeah, I hope it works.
With a blast. As rock explodes and the raw materials of steel are tossed from the earth. The rock is taconite, and the prize inside is crude iron ore. We get at it by grinding the rock to powder and separating the ore with powerful magnets. Then we form and heat the ore into marble-sized pellets that will later be converted to iron. From bituminous coal, we create coke to fuel the iron-making furnaces. We crush the coal, seal it in airtight ovens, bake for 12 to 16 hours, and remove it from the oven as solid carbon fuel. The fuel and pellets come together in the blast.
Can you see this entire machinery? ये पूरा machinery दिख रहा है? This entire machinery is essentially your blast furnace. Yeah, this huge structure is essentially that blast furnace. So I'll resume the video.
Furnace, where we add just enough limestone to remove impurities. From below, a continuous blast of superheated air combusts the coke, intensifying the heat and changing raw materials into molten iron. Sometimes more than 9,000 tons of it a day in our largest blast furnace, where it reaches a temperature of 2,700 degrees Fahrenheit. At regular intervals, we tap this blistering brew into giant submarine ladles.
Do you see these barrels? Do you see these barrels? This is where the iron is collected, by the way. Okay, so at the bottom in the blast furnace, we saw in the diagram, right, molten iron coming out. This is where it is stored. I mean, I know the audio is a little weird. You can listen to it once again if you want.
A continuous blast of superheated air combusts the coke, intensifying the heat and changing raw materials into molten iron. Sometimes more than 9,000 tons of it a day in our largest blast furnace, where it reaches a temperature of 2,700 degrees Fahrenheit. At regular intervals, we tap this blistering brew into giant submarine ladles that ride on rails to the basic oxygen shop, where iron will be turned into steel.
Okay, so the rest of the video just talks about how steel is created, etc., etc. And this video I've taken from Alliance for American Manufacturing. So you can see these videos on YouTube, of course. देख सकते हो. And some people are complaining about commentary being not very loud compared to the background music. Anyway, बढ़िया. तो वापस चलते हैं अपन अपने white board पे. Cool. So my dear friends, that was the entire thing about blast furnace. Now one more thing that you must have heard in the video if you were paying attention is that they said the ore is passed through strong magnets to separate it from the impurities. Yeah, so that magnetic refining process is also used in the separation of magnetic ores. Yeah, so magnetic separation methods can also be used. Fine. So my dear friends, we have already spent like 1 hour in this class. And the questions for today's class are done, by the way. So we are done with today's marathon session. The idea is that you take questions from wherever you want, previous year questions or mock tests or any book or whatsoever you have, and then try to solve that question. In case you don't know the question, then just go to the NCERT and read the theory that is there for that particular section. It's just about reading the NCERT, and now it's the time to do such chapters which have a lot of memory based applications, because you're very close to the examination, hopefully, so that if you remember these things now, close to the examination, you will be able to remember them and solve the questions. Yeah, so every week, let's say once or twice, you can go through the ideas of metallurgy, read the chapter once, tonight or tomorrow or day after tomorrow, and then keep revising it once or twice again and again. Okay? So inorganic chemistry and the chapters of biomolecules and polymers all fall in the same boat. You have to revise them again and again. What's the way of revising? Solving questions and then reading the NCERT wherever necessary. Okay? Cool. So my dear friends, now some people are wondering about the Hall of Fame. मैं Hall of Fame का भी दिखा देता हूँ last class का. Just a second, okay? So I had given a question. Let me quickly show that question. कहाँ चला गया यार? Until then you can enjoy the highway music. एक second ना. So people, this was the homework question. Mark out the most unlikely form of polymerization. It says unlikely form of polymerization, and if you pay a little bit of attention, first one and the second one are very obviously going to get formed. The third one will get formed if only one of the double bonds polarizes. The last one cannot form because free radical generation in that structure is not possible. Yeah, free radicals can be generated here, here, here and here. You can't just generate free radicals without changing the double bonds. Over here it says the free radicals are created without changing the double bonds, so that cannot happen. Yeah, that is not possible. So option number 4 was the correct answer. Now let me switch back to YouTube so that we can see the names of people who have answered this correctly. कित्थे चला गया पॉलीमर? ये रहा. ये लो भैया, हम फिर साइड पे चले गए. So yeah, this is the class of polymers. If you missed it, make sure you watch it, and I will sort the comments by newest first. By the way, the metallurgy questions and theory is done. You can leave if you want right now. I'm just gonna show you the Hall of Fame names, and then we'll just chat with each other for a little while. Cool. So Siv Sanjay, yes, correct. DD Matix, you have edited your answer, bro. What? Something fishy is going on. Farzeen, yes, correct. Kratika, yes. Vibhuti, good. Madhusudan, Naveen, Ishani, Shweta, Aparajita, Swati, Parikshit, Rishika, Amar, Shubh, and Sucheta, and Sanskruti, and Gaming Redemption, and Neeru, and Busa Vishal, and Aditya Kulkarni, and Sri Reddy Sangi Reddy. I hope I'm pronouncing your name correctly, bro. Cool. So yes, very good job, people. You guys were able to give me the correct answers. That's really nice to see. Good job. बहुत बढ़िया. So now what I will do, as usual, I will create the PDF of today's class and I will share that with you guys. And then we'll chat with each other. Yay. चलो जी, time for the PDF to be spammed in the chat box. ये क्या हो गया? रुक जाओ, लिंक कॉपी नहीं हुआ. Yep. Okay. Successfully spammed the chat box, and I will also put this link in the comment section down below. And in the comments you have the details of the crash course as well. So in case any one of you wants to join a crash course in these last few days, the link is given in the comment section down below. Cool. Chalo ji, now we can talk to each other. बताओ भाई क्या हाल चाल. ओए होए होए. Sanjay saying not able to concentrate on physics more. What to do? Sanjay, force yourself to concentrate on physics, bro. Just don't do anything. Take an exercise of physics. Sit for 4 hours. Solve it. Ashok is asking what's the full form of no BS, bro. I think it should be obvious. Dun, 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 dun. Jayant, I'm good, man. How to remember the Ellingham diagram? Soumya, you don't need to remember the diagram. You just read it from the NCERT once or twice. You would understand. You just need to understand that zinc, iron, and copper can be reduced by carbon. Aluminum and magnesium can't. That's what you have to remember. You don't need to remember the entire diagram. Tarushi is saying, would you like to get a tattoo? Not in the mood for that right now. Shyamala Kasuba is saying that today is my birthday. Okay. Happy birthday to you. Boards are cancelled. हाँ भाई क्या करें? Sir, I'm attending your class being in 8th standard. अरे वाह क्या बात है. Okay, Jasjeet, we have already done the mole concept, bro. Let me show you. The playlist is on our channel. Okay, so Jasjeet is watching our videos even though he's in 8th class. Very nice, man. Awesome stuff. So if you go to the homepage of our channel, bro, you just scroll down. This is the series called the Epic Mole. So this is on the chapter of the mole concept. Very nice. You can watch it. If you want to do advanced questions on that, then we have done an advanced question solving session as well. कहीं पे तो है यहाँ पे ये रहा mole. Fine. So yeah, we already have those things on the channel, bro. Sahil, are you there, bro? कि चले गए फिर से? How to stop overthinking about past events? Noel, Interesting question, bro. Actually, I'm thinking of making a video on this idea for the next No BS series. Bro, just understand that the past doesn't exist anymore. So if you're thinking about things that don't exist, then you're just wasting your time, my friend. Have you ever watched any Japanese anime? Not really, yaar. Sanjay is asking, what are the dangerous chemical reactions that you've done in your life? Nothing specifically dangerous, bro. Everything is done in the laboratory using a lot of safety measures. Yeah. If you're asking about Vikas sir of physics, Sant Nagda, sorry, can't pronounce your name properly. Vikas sir from physics, yeah, I remember him, yeah, of course. Rashmi, weird question. Rather not answer anything regarding that over here. Sahil. So Sahil was asking about loneliness. See, Sahil, number one, you're not lonely, bro. We are all over here chatting with each other. If you were lonely, then we wouldn't be doing this conversation. Realize you're not lonely. Next thing that I told in my yesterday's session as well is, see, loneliness is some concept that is created by these Bollywood and Hollywood movies where they want you to make love with someone else. Pointless. Okay. Being with someone, having a partner, it is good for temporary situations, yeah. अच्छा है, होता है, सबकी दुनिया में होता है, and that is how humans survive. They always have been a social, humans have always been social animals. But understand that you on your own are also self-sufficient. So instead of calling this being alone loneliness, please call it solitude. You're solitary. You are good when you're alone, man. Loneliness comes out when you don't feel good with your own self. Why? Ask yourself, why don't you feel good with your own self? Yeah. If you're not happy with your own self, then why or how can you expect someone else to be happy with you? So the thing is, stop calling it loneliness. We humans are fully capable of living alone on our own without interacting with anyone. You're still interacting with me. You're still interacting with people over here on YouTube. So you're not lonely for sure. Okay. If you are alone, then that's solitude. And stop looking at other people. Stop looking at Bollywood and Hollywood movies. Stop looking at TikTok and Instagram people who are just, singing romantic songs going here and there with each other. That's just for selling their videos, man. That they just want to earn money. So stop thinking about that. Being alone is being solitary, and it's a good thing. ठीक है. So अकेले रहने को ये मत सोचो कि वो गलत बात है. बहुत बढ़िया बात है भैया. अकेले रह पाओ, मज़ा ही कुछ और है उसका. Cool. Anyway, Minaz, thank you so much, man. Gaming Club is saying I'm in depression. Bro, see, the thing is, I am not a trained psychologist, so I can just give you my opinion. See, if you feel you are in depression, then do one thing. Try to involve yourself in something that you can enjoy. It could be studying as well. And right now that makes the most amount of sense. So sometimes we think too much about pointless things, about the past, about the future. And that overthinking causes us to, feel very low, very depressed. Sometimes we expect things from people. They don't do it for us. We feel depressed. Yeah. So in order to stop worrying about these distractions, these expectations. Just do something that keeps your brain involved. Yeah. Studying is one thing that you should do, and you can do, and you should do right now, because that will help you build a better career. Yeah. It's always good to be depressed when you have money rather than being depressed when you don't have money. So work towards that, man. थोड़ा पढ़ाई करो, थोड़ा जोश से करो, and try to find some hobby to do, man. Like you can start working out just 1 hour a day, 2 hours a day in the morning or in the evening or before sleeping. Just work out. You can do anything to work out. Yoga kar lo, push-ups, pull-ups, etc. So what that will do is that will create a surge of good hormones in your body. Dopamine will get secreted in your body for a prolonged period of time if you work out daily. So depression essentially is just the imbalance of chemistry, the imbalance of chemicals in your body, and you need to work towards creating the dopamine chemical in your body through natural ways. And yeah, so the idea is to involve yourself in something that you can enjoy. Okay. हार्दिक, आई डोंट थिंक इट विल बी पोस्टपोन्ड मैन, मेरे को लगता नहीं है, हो गया तो पता नहीं. Gamer Topper is unable to join the Telegram group, bro. If you have a Geo SIM, it won't be possible to join the Telegram group. Amino acids, we've already made a video on that, smart learning. Watch my class on biomolecules. We've already done amino acids over there. Okay. Suyash, bro, you can watch the class anytime you want, man. You can watch the class in the afternoon as well. Sri Sagar, the Vedantu's office is an HSR layout. Kashyap is saying, how do I overcome the pressure from parents? Don't worry about it, bro. Parents always want you to do better because you know they are your parents. So they are also coming from a point of concern, from a point of worry about you. बोलते हैं, बोलेंगे, सुनो, listen to them, but don't take it too hard, because you are putting your efforts, right? You are putting some efforts, you are trying to do your best. Do that. Results will follow. Parents will also realize कि हाँ, my child is doing well. ठीक है? So parents just want you to be happy in life eventually, isn't it? If you are doing what you are supposed to do, if you are doing what you want to do, and if you're happy in that, slowly and steadily they will stop putting this pressure on you. Okay. Beena is saying, can you talk about the scope of engineering in India? See, go to a good college, you will get all sorts of scopes here. That's not something you need to worry about. ठीक है, बढ़िया. Sahil, what situation do you need to get out of, bro? I am playing PUBG. How can I get out of this? No need to get out of PUBG. Just play it for 1 hour a day and then stop. Yeah, play it for 1 hour a day, but don't play all the time. Ganesh is asking, do you exercise every day? I used to. These days in the lockdown, I am very lazy. All I do is sleep, wake up, study, teach, cook food, eat, sleep. उसी में बहुत time लग जाता है यार. Snigdha is saying, what are your views on BSc Honours in Chemistry? Snigdha, if you are doing BSc or MSc, then do it from a very good college, because if you do it from a not so good college, then the opportunities later on are very less. Okay, so try doing them from IISCs or IITs or some government reputed college. Otherwise, just go for some other branch. Okay, so always prefer a good college over a good branch. Okay, Dhanush, thank you so much, bro. What are topics taught in chemical science in acha. So I assume you're talking about chemical engineering, Sunny. All the topics are related to mathematics, and in chemical engineering there is very less chemistry. There is a lot of physics, there is a lot of fluid dynamics, mechanics, and lots of mathematics that is dealing with how to optimize things in the industry. So if you do chemical engineering, it is hardly any chemistry. Okay. How to memorize the ores? Yes, just read the list every 2-3 days, man. Shijit, electrolysis will be done with the fused metal only, bro. हाँ तो Sahil, that's expectations and only just, that's what I said, right? Stop having such expectations from anyone in life. Why do you want to expect anything from anyone, even from yourself? Chill, maro. Whatever you are doing, just do it to the top quality. Good results will automatically follow. Yeah, if I now start expecting that I will grow 10 kgs of muscles and I will have 6-pack abs like 3 months from now, I am bound to get depressed, bro. So unrealistic expectations are bad. Please tell yourself not to have them. Just do the best you can. Eventually the results will automatically follow. So instead of thinking about the goal ki ye hona chahiye, stop thinking about it. Be where you are and do the best you can. Results will automatically follow. So मत सोचो भाई expectation का इतना. Ponappu is asking, do you like physics? What's there not to like about science, man? Minaj, that sounds good, bro. qualitative analysis. Sanjay, I will give you guys some study material for that. Let me search for it. Chalo dosto, half an hour we've spent chatting with each other. Anyway, so I hope you enjoyed today's marathon class and I hope you understand how to study inorganic chemistry chapters. If you enjoyed the class, please hit that like button. And I will see you guys once again on Monday with carboxylic acids. I know I haven't given the schedule for later things, so let me tell you what's coming up for you guys on this channel. So in the next week we will cover carboxylic acids and we'll cover the chapter of hydrogen. I will try to find out a material for qualitative analysis and I will try to give that to you guys using the community page of our channel. And after we are done with the next week, we will start solving NTA tests. So we'll start with the latest test. I think right now test number 37 is there in the NTA app. So we'll start with that and then we'll keep on solving the NTA tests until the examinations are there. Yeah. So good that 90% of our chemistry is revised, 95% in fact. Only carboxylic acids and hydrogen chapter is remaining. Congratulations people. And yeah, that's it from my side for today's class. See you very soon on Monday at 8:30. If you are in 11th class, I'll see you tomorrow at 7 for the chapter of periodic properties. Good night. Take care. And Chandana is asking best book for this chapter, NCRT.